أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Starting with the great name of Allah, who is the most merciful and gracious. Our today's topic is about the epidemiological or research study designs, especially the quantitative research or quantitative designs. What are the objectives, the definition of study design, the different classification of study design according to WHO and according to other authors of different books, like for example, Leon Gordas. There are so many books of epidemiology and they have classified the design differently, but having the same meaning. Like for example, if one author has classified the design in a different way and the WHO classification is somehow a slight difference, but that has not got a major difference. They are almost the same. So we will be discussing today the different study designs and its classification. So first, what is study design? Study design is basically a specific plan or protocol that allows the investigator to translate his or her conceptual hypothesis into an operational one. Means whatever he is thinking about, the relationship of two variables that exist between the two variables, between the disease and the exposure, between the exposure and the outcome, or there is a mean difference between the two groups of population. These things of hypothesis, these kinds of hypotheses, and you bring that into an operational one, means you are testing those hypotheses whether really that association or whatever you want is an outcome to have, whether that exists or not, that really exists or not, whether it is there or not. So now, starting the study design, I have a presentation on study design. So I'll be discussing each slide one by one with the common examples, and inshallah you will better understand about all the study design. Those are epidemiological quantitative designs. So let me share you the presentation. The objectives: study design, classification, descriptive and analytical study design in detail. A design, first definition. A design is a specific plan or protocol for conducting the study which allows the investigator to translate the conceptual hypothesis into an operational one. A set of study design, a set of defined steps required to carry out research on a problem under study, and the design will define how study subjects are selected. Whenever you conduct a research project or research study, your title shows what will be the study design. How study subjects are selected, the study design is basically from step one to the last step of conducting a research. That is a study design. And when you choose a specific one in the quantitative design, that is called a study type. So the study design is, I have said, that it shows all the steps from step one to the end of the step. So the last step, how do you conduct the research study? What will be your sample? How would you collect the data? How would you analyze the data? What are the certain statistical tests that you will apply in your research study? So it talks about it. How study subjects are selected? Mean your sampling technique, method of sample size determination, whether you are calculating through formula the sample size, or you are calculating the sample size through some software, like for example, a RAWSoft software. There are other software, for example, EpiInfo, G-Power, so many, and sample size calculators. These are the software that you can use for calculating your sample size. Inshallah, in other lectures, we will be talking about how to calculate sample size through formula and through software. The procedure of data collection, how would you collect the data? Whether it is a survey type data, you have to go there yourself and you have to ask questions from the participant and fill your questionnaire, or you have to conduct an experimental research You have to intervene, you have to observe, and then you have to collect the data after the intervention and before the intervention. And procedure of data analysis, how would you analyze your data? Whether you will analyze through SPSS, through Microsoft Excel, through other software, and the types of statistical tests that those are required for different type of studies. There are different tests to be applied. For example, if you want to see an association between the two categorical variable, you have to apply chi-square test. If you want to see the mean the difference between the two groups, the mean difference between the two groups, you have to apply independent sample t-test. If you want to see a difference in the means which are more than 2, means if the samples are more than 2, there are more than 2 independent populations, so you will take more than 2 samples and you will apply analysis of variance to see whether the mean is different across all groups or not. So these are some of the examples of statistical tests and different type of study design. There are other other statistical tests. Some are parametric and some are not parametric. The parametric tests are those tests which are applied on the population which are normally distributed, and the non-parametric tests are those tests which are applied on the population which are not normally distributed. The proof for evidence-based medicine is all collected via research, which uses a variety of study designs. Different study design provide information of different quality. Of course, if you have qualitative design, that will produce somehow different information. If you have experimental design, a different information. If you have observational study or cross-sectional study. So there is a variation in the quality about information from different type of study design that you are collecting. Therefore, you need to understand the strength and limitation of each type of study design is applied to a particular research. And maybe the cross-sectional study may not be that much stronger as the RCT, which needs a strict protocol and which is the best study to go for causal relationship between the two variables. This is the classification. Mainly the epidemiological design or quantitative design are classified into 2 groups, the descriptive designs and the analytical design. This classification is the WHO classification of study designs. And the first type, which is a descriptive research or descriptive design, it is further divided into 2 groups: population-based, which is also called ecological or correlational study, and individual-based. In individual-based studies, there are case reporting, case series, and cross-sectional surveys, and descriptive research. What is population-based study? The population-based study is a type of study where the unit of analysis is group of people, not an individual. For example, if you are living in an area where there are so many industries and there is a town, a city, which is closer to those industries, and if you want to see the effect of that pollution, the pollution from those industries and the effect of those pollution on the population. So you will study the whole population rather than a small sample size. And that is called a population-based study, ecological study, or correlational study. The best example of this study is maternal mortality rate, infant mortality rate, under 5 mortality rate, neonatal mortality rate, which is taken as a group, not an individual. An individual-based study, it may be a single individual, it may be several individuals, and it may be a bigger sample. So most of the time, the individual-based studies are talking about the sample. You have a bigger population, but you cannot study the whole population, and you will take a sample which is representative of that population, and you will study it, and then you will generalize the result to that population. So the case reporting is a type of study where it is about the unique case. A case, for example, if the first case of COVID-19 developed in a particular country, for example, China, they were surprised to see these are the signs and symptoms, this is the condition of the patient, and if you report all the signs and symptoms, the pathophysiology of that disease in a single individual, that would be called as a case reporting. And the case series, when the same disease you found in several people, from 3 to 7 people, that is a case series, or multiple people, that is a case series. And when you take, and in the last one is the cross-sectional surveys, which needs a single group. For example, if you want to go into a community and you want to determine the prevalence of diarrhea in that community, so you will take a single sample and you will ask the question that you have in your questionnaire, a type of survey, and you will collect the data. Then you will describe your sample, the factors, the disease people, and then you can also formulate the hypothesis in cross-sectional surveys. This is basically for formulation of hypothesis. Like for example, if you identify so many factors and there were so many people who had got diarrhea, and you have to associate each factor, maybe unhygienic condition with the diarrhea, maybe tap water with the diarrhea, maybe hand washing with the diarrhea. So you can think about the association between the factor and the disease, and then you can test that association in the analytical studies. The second type is the analytical research. In analytical research is a type of study where you need to test the hypothesis that you have already formulated in the cross-sectional studies. And it is further divided into observational and experimental studies. Experimental are also called interventional studies. Observational studies are those studies where you don't need to do any kind of intervention. On the other hand, in experimental studies, you have to do a kind of intervention and you have to wait for the change in the dependent variable. So the intervention that you do, you will see the effect as well. So that is an experimental study. Let's move ahead. The observational studies are further divided into cohort study, case control study, and comparative cross-sectional study. This cross-sectional study is called comparative cross-sectional study because you will be having two groups to be compared with each other. And then the experimental studies are further divided into randomized control trials and quasi-experimental designs. Now we will be discussing each study design separately in detail. Study types, descriptive studies. What are the objectives of descriptive studies? These type of studies aim to know the frequency of disease, knowing the distribution of the disease, distribution with time, place, and person. Where is the disease? What segment of the population has got the disease? And what is the season of that disease? Whether it develops in winter, it develops in summer, or in any other season. And developing the hypothesis, as I already said, that you have to formulate the hypothesis in descriptive type of studies. And observational analytical studies are basically for testing the hypothesis and for establishing an association. Establishing association between the factor and the disease, testing of a hypothesis which you have already formulated in the cross-section studies, you have to test those in the analytical studies. And in the observational analytical study, you have to test the hypothesis, you have to look for the association, but you are not intervening. Experimental or interventional studies, you will go for strength of association, how much is the association, and establishing the cause, the factor causing the disease, that is establishing the cause. Strength of association, how much is the association between the factor and the disease, a stronger association or a weaker association. And this is a flow chart of different type of study design: descriptive, hypothesis forming, population based ecological, individual case series, case studies and case series, and experimental analytical hypothesis, observational case control, cohort and cross-sectional, interventional, your RCTs, and your quasi-experimental designs. Now take it further. The researcher studies but does not alter what occurs. That is observational studies. You are not, the researcher is not supposed to do any kind of intervention. He or she just to observe and collect the data. The researcher intervenes to change reality, then observe what happens. That is an experimental design. You have to do a sort of intervention and you have to wait for the effect of that intervention, whether it brings change or it does not bring change. Descriptive studies only do not examine association between exposure and health outcome. Generally, the purpose is to describe the variability in health outcome and or formulate hypotheses, as I have already said. A descriptive study involves describing the characteristic of a particular situation, event, or case. Descriptive studies can be carried out on a small or larger scale. Types of descriptive studies is the case study, a study of one disease individual providing a detailed description of an uncommon disease, provide timely or rare information. As I have already discussed, like the first case which was occurred in China of the COVID-19, so that was a unique case. That was a unique case, and that can be studied in case studies. Or a single patient clinical history described in detail and then discussed in relation to the literature, almost always a rare, unusual, or atypical case. You cannot carry out all the time case studies. If you find a case which is quite unique and atypical, then you can go for a case study. In the case series, a study of multiple occurrences of unusual cases that have similar characteristics. Investigator can calculate the frequency of symptom or characteristic of people with the disease. The result may generate causal hypothesis. Neither a case study nor a case series includes a comparison group. Descriptive study design, case report, one case of unusual finding, and case series, multiple cases of the same, of a single disease. Cross-sectional surveys, subjects or institutions are surveyed in order to describe the prevalence of health outcome and or characteristic of a population. So that needs a bigger sample size than case report and case series. Ecological and ecological study focuses on group of people rather than individual as the unit of analysis, as I have already discussed. The variables include measurement taken at the group level, for example, infant mortality rates of different countries. Types of observational studies, analytical designs included cross-sectional comparative studies, case control studies, and then cohort studies. Analytical non-interventional studies, cross-sectional comparative non-interventional, case control is also non-interventional, and cohort studies also non-interventional study. Now, time is key. If you go into a community and you collect the data on the disease and exposure at the same point in time that you would study in cross-section studies. And if you go from the outcome towards the exposure, like you have outcome in your hand, but you want to know what will be the exposure in these patients, so you have to go retrospectively from present to past, and that we study in case control. A cohort study is from present to future. You have an exposure, but you have to wait for the outcome. You are interested in outcome. Case control study is always conducted on a rare outcome, and cohort studies are always conducted on a rare exposure. Here you wait for the outcome, and here you go back retrospectively to know about the exposure and the association between exposure and the outcome, the disease. Design of a cross-sectional study, first you have to identify the subjects from the population, and then there may be possibly 4 groups. Data taken at one time. When you take the data from an individual, the person or the individual may have the risk factor and the disease present, both of them. For example, a person with diarrhea and the person is using tap water. So both the disease and the risk factor may be present in an individual. And on the other hand, so there may not be one individual. There may be, if you have a sample size of 200, you may have 30 people or 40 people who have a risk factor, and at the same time they have disease as well. And there may be a group of people who will be having no risk factor, means they will not use the tap water. They first will boil the water and then they will cool it down, let it down cool, and then they will use. And the disease may be present. Despite of no risk factor, they may have the disease. So you can find a group like this. And on the other hand, a person or a group of people, when you are conducting a study, those individuals may have risk factor, but they don't have the disease. For example, in a community, a person is using tap water, but he or she does not have the diarrhea. So you can have a group of these people. And on the other group where there is no risk factor and no disease, a person is having no risk factor. For example, he is hygienically good. He is using pakka water, that is boiled water, and he has no disease, diarrhea or any other disease. So you have possibly these four groups. Cross-section, the cross-section study measure the prevalence of health outcomes or determinants of health are both in a population at a point in time or over a short period of time. Cross-sectional design, information is collected from each subject at one point of time, used to provide a snapshot of a population at a point in time. And snapshot of population means you have to go in a community, in a population once, and then you have to come back. You are not supposed to go back to see whether to collect the data again. There is no need. The main outcome measure is prevalence, limited to the measurement of risk factor and outcomes at one simultaneous point in time. Examples are screening surveys, knowledge attitude and practices. CAPE surveys are mostly the common examples of these kind of studies. So what you have to do, you have to begin with the target population where you want to generalize your results, and then you will take a sample, and from the sample, the gather data on exposure and disease. There are possibly 4 groups that you may have in your study. As I have already discussed, expose the risk factor and the disease, a group of people, and a group of people who were exposed but they do not have the disease, and a group of people you can have in your study who are not exposed to a certain factor but still they have the disease. And the fourth one, the group of people who are not exposed and they don't have the disease. 4 possible groups are there. And this is, through a table. You can make a table of these A, B, C, and D. Exposed, they have the disease, and some of them do not have the disease. Not exposed, they have the disease, and they do not have the disease. Further, it is explained, exposed and not exposed, they have the disease, and they don't have the disease. And exposed group, you have the disease. These are the exposed people. Some of them will have the disease, some of them will not have the disease. These are not exposed people. Some of them will have the disease and some of them will not have the disease. So taking it further, prevalence of exposure, compare in disease and non-disease people. A over A plus C will give you the prevalence of exposure, compare in disease and non-disease people. The prevalence of exposure, how many people were exposed and how many people were not exposed. So A or A plus C. A are the people who are exposed and who have the disease, and B or B plus D. B were the people who were exposed but they don't have the disease. A plus C, that is a combination of exposed and unexposed but they have the disease, and B plus D, this is the combination of people who exposed and not exposed and they don't have the disease. Or A or A plus B versus C or C plus D. Over here, the prevalence of disease, compare in exposed and non-exposed people, it shows the prevalence of disease, and this shows the prevalence of exposure. A over A plus B. A, the people, the prevalence of disease, compare in exposed and non-exposed people. And taking it further, the cross-sectional prevalence of heart disease in a sample, this shows the different factors related to heart. For example, smoking, poor diet, alcohol, and sedentary. You filled a questionnaire, and you made 4 groups, 1, 2, 3. These are the factors which were identified during your survey. So prevalence of risk factor in study sample, a snapshot of a disease. Advantages of cross-sectional, outcomes and exposure measure at the same time, uncovers association for further studies. This is The advantage of cross-sectional studies that it collects data on outcome and exposure at the same time. You will be having the disease people and you will be having the associated factors as well when you do or conduct a survey. It uncovers the association for further study, means you formulate hypotheses and then you test in analytical studies to find an association between the variables and the outcome. Useful for hypothesis generation, quick and cheaper, no follow-up is needed. Best way to determine prevalence, these are called prevalence studies. Questionnaire, interview based, useful. You don't need to have intervention. Useful for assessing practices, attitude, knowledge, beliefs, utilization of services, etc. Whether people utilize services or not. Advantages of cross-sectional study can be conducted to assess the healthcare needs of the population. The healthcare needs of the population, when you ask the people, they will tell you what are their needs, and helpful in measuring access utilization of health services. It is also helpful in measuring access and utilization of health services. You will ask the people whether they are utilizing the existing services or not. And you will also ask them whether the existing facilities are in their reach or not, helpful or not. So helpful in measuring access, provide information between disease and various variables, provide information regarding distribution of a disease, and determine burden of the disease in a population, so helpful for planning purposes. When you determine the magnitude of the disease, that these many people in a particular community are ill people, are people with the disease, then you can plan intervention for them. Any health facility to be established there so that the people take benefit of those facilities and you can control the disease. Limitation, no temporal or time sequence, so gives no information whether which comes first, that is cause or disease. It means that if you don't spend the time, you will not know whether disease comes first or the factor first comes. When you spend the time, like analytical study design, for example, cohort design, you will know that this was the factor and this was the disease, so you know which comes first and which comes later. And you will also know the association between the factor and the disease. So it needs time. As in prevalence studies, you don't spend time with the people, so you cannot go for any temporal association. You cannot establish an association between the factor and the disease. Gives no idea about natural history of the disease or etiology, gives no measure of a new case's occurrence, and not used for rare exposure or rare outcome. For rare outcome, you have to go for case control study, and for rare exposure, you have to go for cohort study. So these are not studied in cross-sectional studies. Design of a cohort. Now we will move one step forward. For in analytical studies, for cohort study, define population, there is no randomization. So you need not to have any randomization. Randomize the random fashion of the individual to be divided in two or more than two groups. Identify expose and not expose. The people who were exposed to a certain factor and another group were not exposed to a certain factor. This will further be divided into two groups, whether these exposed people to a certain factor, they develop a disease or they do not develop. Some of the people develop the disease, some of the people will not develop the disease. And not exposed people, there are also two possibilities. Some will develop the disease and some will not develop the disease. Cohort studies are also called follow-up or incidence studies. Because the data on exposure and disease refer to different points in time, cohort studies is also called longitudinal studies. Because you have to have follow-up visits and you have to study the individual for a longer period of time. Even you can study them for 5 years, 10 years, 15, 20, or 25 years. That depends upon the outcome, how much time it takes. So cohort studies have also been called prospective study because it goes from present to past. The observation of a cohort study over time to measure outcome. Synonym terms are used: follow-up, longitudinal, and prospective studies. Cohort studies, birth cohort, all individuals are defined. That is further explanation of the cohort. What is cohort basically? Is a defined geographical area born in the same period, usually a year. Inception cohort, all individuals assemble at a given point based on some factor, for example, workplace. Exposure cohort, a group of individuals that potentially share a common exposure, for example, a radiation. For example, a group of people who recently joined a hospital and they are either technologists or they are radiologists and they are working in the same area. So that is a cohort, that is a cohort of the people who were exposed to a common exposure, that is a radiation. Disease cohort, a group of individuals with a specific disease. There may be a disease cohort as well, a group of people who develop a particular disease. Now, there are certain steps that has to be followed while you are conducting a cohort study. So cohort studies are conducted in 3 fundamental steps. The first one is you have to identify cohorts of exposed and unexposed individuals who are free of the disease or outcome of interest at the beginning of the study. One group who is exposed to a certain factor and the other group who is not exposed to a certain factor. For example, one group is smoking and the other group is not smoking. One is smoker, the other is not smoker. Observe each cohort over time for the development of the outcomes of interest. And then you have to wait. You have to make a follow-up visits after 2 months, after 3 months, regular visits, and you have to observe both the groups for any sign and symptom of the outcome, and then compare the risk of outcome between the 2 cohorts, whether the incidence is more in the exposed group or the incidence is more in the unexposed group. And this is the cohort study design. That is a direction of inquiry. How would you make an inquiry? First, the population, then you have to identify the people without the disease, divide them into 2 groups, the exposed and not exposed. Expose to a certain factor and not expose the group who is not exposed to a certain factor. And then you have to follow them regularly after periodic visits. You have to make periodic visits, you have to make a follow-up visits, and then you have to see for the outcome or the disease. So there are 4 possible groups. The exposed group, there may be certain individual who may develop the disease at the end of the study, and there may be individual who will not develop the study. And in the other group who is not exposed, some of them will develop the disease and some of them will not develop the disease. So types of cohort studies: prospective cohort that starts from present and goes towards the future, and retrospective cohort, which is also called a historical study, non-concurrent cohort or historical cohort study. The direction of retrospective cohort is like this. I'm going to explain it on the board. This is present, and you have to go retrospectively from present to past. And you have to define the exposure. What will be the exposure? And then you are selecting this group, and then you come again to this point. So you went retrospectively, and again, you are studying these individual prospectively. So you come back towards this point, the present time. This is called a retrospective study. And if you want to study this group in future for further outcome, whether this exposure is responsible for the incidence in this group, for more incidence in this group. So you have to study this group in the future as well for a certain period of time. And when these 2 combine, the retrospective and prospective, this is called an ambidirectional study. This is called an ambidirectional study. So prospective, that is from exposure to outcome, and retrospective, that you have to go from the outcome towards the exposure. And in ambidirectional, what you have to do, you have to go from present to past, and then from the past towards the present, and then towards the future. So that is an ambidirectional study. A time frame for hypothetical prospective cohort study conducted in 2000. This is an example. Define population, non-randomization. There is no randomization for this type of study. And you are dividing the groups into two, exposed and not exposed, and there are 4 possible groups. 2 groups for each exposed and non-exposed. Prospective cohort study, investigator starts the study from the beginning with the identification of the population and exposure status, exposed, not exposed group, follow them over time for the development of the disease. You have to follow them for the development of the disease. You have to make periodical visits and see for the sign and symptom for the exposed and non-exposed individual. Takes a relatively long time to complete the study, as long as the length of the study. So it depends upon the length of the study. It may be 5 years, maybe 10 years, and maybe 15 years, or it may take more than this time, more time. So prospective cohort, again, you have to define your population, and then the individual who are free of the disease, you have to divide them with exposed and non-exposed, one group who is exposed and the other group is not exposed, and you have to follow them in the future. So this is a kind of retrospective cohort. Like for example, you are standing over here in 2000 and you want to study a group who has, for example, in a hospital who has already enrolled in 1980. So you have to go back to 1980, their files, and then you have to start the file from the first page and come again towards 2000. And if you want to study this group further, you have to study them in the future as well. So they will, both the type of study will get together and make an ambidirectional study. Retrospective cohort study, investigator uses existing data collected in the past to identify the population and exposure status, exposed, not exposed. This is specifically related to the data that exists in the hospital. Determine at present, or any clinical center, determine at present the development status of the disease. Investigator spends a relatively short time to assemble study population and the exposed and not exposed group. This is a cheaper one study because you will not wait. You can study a file in the hospital within a month, within 10 days, within 15 days, but for prospective study, you have to wait for a longer period of time. So determine disease status at the present time. No follow-up is needed in this type of study. That is retrospective study. Combine prospective retrospective study, as I have already discussed, investigator using existing data collected in the past to identify the population and the exposure status, exposed, not exposed group, follow them into the future for the development of the disease. Investigator spends a relatively short time to assemble study population and exposed and not exposed group from past data, will spend additional time following them into the future for the development of the disease. Cohort study design. Cohort study measure the incidence in both the exposed and non-exposed group. It also measure the relative risk, which will the relative risk which will show you or which will give you the strength of association. Relative risk will give you the quantification of association, and then the attributable risk, how much the exposure is related to the disease, that is an attributable risk. So here, first select the group exposed and non-exposed. These are the different types of, some will develop the disease, some will not develop the disease in the exposed and not exposed. And these are the total A plus B, and A over A plus B is the incidence rate of disease. C over C plus D is the incidence rate among non-exposed. In incident exposed A over A plus B, and incident unexposed C over C plus D. Incidence total exposed plus unexposed A plus C over A plus B plus C plus D. That is incidence and total, both exposed and unexposed group. And relative risk, cohort study determine whether there is an association between exposure to effect and development of a disease. So the relative risk, as it is calculated through this formula, incidence and exposed and incidence and unexposed, A over A plus B divided by C over C plus D. And attributable risk, this is determined. Let us take an example. I'm going to explain it on the board. Let's suppose we have this table, and these are 4 cells. disease positive and disease negative. That is disease. This group is exposed and this is non-exposed. This is A, B, C, and D cells. For example, here 50 people out of 120, 70 did not develop the disease. Here 40 people developed the disease, and out of let's say 150, 110 did not develop the disease. So what will be the relative risk? The relative risk will be equal to A over A plus B divided by C over C plus D, which is equal to A, which is 50, divided by 120, divided by 40, divided by 150. Now take it further, 50 divided by 120, multiply by 150 and divided by 40. So this will cut with this 0, and 15 5s are 75 with this calculation, and 48. So if you divide 75 on 48, that will give you and again that is 1.1 something or something like that. So that is a relative risk. Let's assume you have a relative risk of 5. Assume that you have a relative risk of 5. So what does that mean? That those people who were exposed to a certain factor, they have 5 times more, they are 5 times more at risk to develop the disease as compared to those people who were not exposed. That is the interpretation of relative risk. If relative risk is equal to 1, mean there is no association between the disease and the exposure. If relative risk is more than 1, there is a positive association between the disease and the risk factor. And if it is less than 1, it means there is a negative relationship between the disease and the outcome. And this is also called a protective factor then. Let's take it further. This is determined by the attributable risk, which is defined as the amount or proportion of disease incidence or disease risk that can be attributed to a specific exposure. The excess risk is called attributable risk. Attributable risk is calculated as a risk difference, incidence in exposed minus incidence in non-exposed. Advantages of cohort studies. Useful for rare exposure. This study is conducted on rare exposure, and it is useful for more than one outcome. If you have a single exposure, it may give multiple outcome. Like for example, if there is cigarette smoking and the outcome is lung cancer, you may also get the people with myocardial infarction and with hypertension. Incidence of the outcome and incidence rates. Temporal relationship between exposure and outcome is clear as exposure status defined at the start of the study. Because you will spend time, 5 years, 10 years, so you will know whether the exposure is associated with the disease or not. That is called a temporal relationship or temporal association. If prospective minimizes biases in measurement of exposure, sometimes the only ethical or legal way to do study, stratification, nested case control, and multivariate analysis can be applied in such type of situation or studies. Disadvantage is not good for study of rare outcomes. You cannot collect a huge sample of rare diseases, so it is not possible to conduct this cohort study on a rare outcome. If retrospective, they rely on the adequacy of records, and the record may be authentic, may not be authentic. It may contain unnecessary data as well. Exposed may be followed more closely than unexposed. If prospective, they can be very expensive and slow. As they are follow-up studies, the validity of the result is highly sensitive to losses to follow-up, migration, withdrawal, lack of participation, and death. This is the very common disadvantage of a cohort study. You may lose the individual in your sample. So at the end, if there is less number of individual of your sample is left, then you cannot generalize your result on the whole population. So whenever you conduct a study, you have to take a larger sample. So if the people leave the study, they migrate, that will not drastically affect your results or your sample size. Now, case control study, you can see the case control study is somehow different from the cohort study because it goes from present to the exposure, the past. Another difference is that you may have multiple exposure for a single outcome, and odds ratio is calculated in case control study rather than relative risk. So we have also, because it is analytical study, we will be having two groups, one without the disease and one with the disease, and we will study them in the past regarding the exposure. So case control study, analytical epidemiological study design in which individual who have the disease under study, also called cases, are compared to individual free of disease regarding past exposure. Exposure differences between cases and control are helpful to find potential risk or protective factors. The purpose is to determine if there are one or more factors associated with the disease under study. And what does it mean? The protective factors. When we calculate the odds ratio, similarly, like relative risk, if it is equal to 1, there is no association. More than 1, there is a positive association. Less than 1, there is a negative relationship. So if you calculate odds ratio for a certain exposure and outcome, and the odds ratio is less than 1, mean that factor is protective for that disease. So the individual with the disease should be exposed to this factor so that they can control the disease, or there may be no further development of the disease. To examine the possible relation of an exposure to a certain disease, we identify a group of individuals with the disease called cases, and for purpose of comparison, a group of people without the disease are outcome variable called control. The study compared the occurrence of possible causes in cases and in control. And this is the present, the direction of the study. How would you make an inquiry? First, the cases and the control, cases with the disease, control without the disease. And then you have to ask them for the risk factor. So risk factor may be present in the cases, may not be present in the cases, and risk factor may be present in the control, may not be present in the, and then you have to compare. Then you have to compare both the outcome and the control through odds ratio. A case control study is usually conducted before a cohort or an experimental study to identify the possible etiology of the disease. It costs relatively less expensive, can be conducted in a shorter time. For a given disease, a case control study can investigate multiple exposure, as I have already discussed, when the real exposure is not known. A case control study is preferred when the disease is rare because investigator can intentionally search for the cases. A cohort study of rare disease would need to start with a larger number of exposed people to get adequate number of cases. Advantages of case control study: can be carried out quickly and quite cheaply, useful just like survey type study. Useful for rare disease and outcomes because you may collect a sample of a rare outcome to be investigated for the exposure in the past. Can study multiple exposure for a single outcome. If you have a disease that may have more than one exposure, for example, a person with lung cancer might be exposed in the past to smoking, to wine drinking, to pollution, and to other factors which are associated with lung cancer. So there may be multiple exposure. Case control studies can be ideal for the study of rare diseases or those with a long latency. Compares odds of exposure between cases and control. Disadvantages: selection of control population, overmatching. This is very the bigger disadvantage of this study, that selection of control group from which population you have to select the control. The proper way of selecting the control is to take the brother of a case, a relative of a case, if not the neighbor of the case, or from the same community. Beyond that, that will not give you good results. Overmatching, you have to match with respect to gender, with respect to age, and with so many factors. So that is a problem. Information bias is an exposure's similar status. Information bias, some will give you good information and some will not remember. So that becomes a bias. Determine after outcome has occurred, for example, recall bias. Selection bias, especially regarding control, cannot establish sequence of temporal association, cannot be found or cannot be established because you are not spending time with the individual. You just go and just like cross-section study, you are collecting the data. Not good for rare exposure because you don't know what is the exposure. For the rare exposure, it is not a good study because the disease with long latency and how much will you wait. So for rare exposure, the cohort study is a good one, and for rare outcome, the case control study is a good one. Cannot usually be used to estimate incidence, relative risk or attributable risk, can only be calculated, that is odds ratio. Experimental study design, the type of study design in which you intervene. You have to do certain types of intervention and you have to see the effects of those intervention. So randomized controlled trial, taking it further, an epidemiological experiment in which subjects in a population are randomly allocated into groups, usually called study and control groups, to receive and not receive an experimental, preventive or therapeutic procedure, maneuver or intervention. That is the definition of maneuver. Further definition: randomized control trial, allocation of participants to various groups in random fashion, and a control is used to compare the effects of a particular treatment. Trial, that is an experiment conduction. And this is a flow chart of this type of study. First, the reference population. You have to take the target and the study population then, and from them you have to collect a sample, and the sample through a random allocation, that is randomization. You have to divide the sample size into two groups. One is control and the other is interventional group. And in control, you are not supposed to do any kind of intervention. And in interventional group, you have to carry out certain intervention to see the effect of that intervention. So at the end, you will compare the effect of that intervention in control and interventional group, whether there is a difference or not. So the true experimental design or CT has three characteristics. First is the randomization. The researcher takes care to randomly assign subject to the control in experiment. There, it shall not be a biased one. When you do randomization, bias is automatically removed. You are not biased then. Each subject is given an equal chance of being assigned to either group. This is what the definition of randomization. Control, the researcher introduces one or more control group to compare with the experimental group. Manipulation, the researcher does something to one group of subjects in the study, and the strength of experimental studies is that by randomization of confounding variable. You have to have a strict protocols and you randomize so that you can control the confounding factors. In randomized control trial, we begin with a defined population. Subject in the study population randomly allocated to intervention in control groups, and the results are assessed by comparing outcome. The basic design of RCT is given below. First, the study population, sample population randomization, control group and study group. You have to carry out certain experiment or intervention in this group, and there is no need of intervention in the control group. No manipulation or intervention, and there is an intervention. Last, data collection in both the groups, and then you have to compare. Allocation of study subject randomization, random, governed by chance. All the individuals have equal chance of being selected in the control and in the cases, the intervention group. Randomization allocation of individual to groups by chance. Each sampling unit has the same chance of selection. Randomization is the process by which allocation of subject to treatment group is done by chance without the ability to predict who is in what group. Primary purpose of this randomization is to prevent bias in allocating subject to a treatment groups, avoid predictability, who will be in what groups. Secondary purpose to achieve comparability between the groups, there is no guarantee. Comparability whether the intervention works or not, but is not guaranteed. It does not mean that the intervention will bring any change, but it is possible whenever the researcher conducts a study, he is looking for the effect of the intervention, but it is not necessary that this intervention will bring a change or will bring an effect. Stratification randomization is random assignment within groups defined by participant characteristics such as age or disease severity intended to ensure good balance of these factors across the intervention group. So this is what stratification is. Like for example, you have 1,000 patients, 600 males and 400 females, stratify by age. You have to stratify them by age. 360 are young, 240 are old. And then in female, 300 are young and 100 are old. And further, randomize each subgroup so that you can have a balance. Like for example, the older females are brought into this group, and from here you have to take some of the people to this group. So there shall be a balance between the two groups. So male and female combined together, young and old, they are getting together, and that will give you good results then. So bias will be minimized in this way. Randomization trials are gold standard for study design because the potential for bias selection into groups is avoided. Blinding represent an important distinct aspects of randomization control. Blinding is also called masking. Whether the investigator know, whether the participant know, or whether the person who is analyzing the data, they know about the research or not. So if you blind the data collector, the participant, that is a single blind, the investigator, double blind, and the data analyst, that is triple blind study. So the term blinding masking refers to keeping trial participant investigator, usually healthcare provider, assist those collecting outcome data, unaware of an assigned intervention so that they are not influenced by that knowledge. Blinding prevents bias at several stages of a trial. Masking or blinding is used to increase the objectivity of the person dealing with the randomized study to prevent prejudice. Subjects who can be masked or blinded may be study participant, it may be caregiver or treaters, data collector, assessor of outcome, data analyst, and maybe investigators. Level of masking may be non-blinded, open. All the people know what is going on. A single blind, double blind, and the triple blind. Prejudice meaning preconceived opinion that is not based on reason or actual experience. A placebo, from the Latin for I will please, is a medical treatment, operation therapy, chemical solution, pills, etc., which is administered if it were a therapy, but which has no therapeutic value other than the placebo effect. And that creates an ethical issue whenever you are conducting an experimental study. A nocebo, from the Latin for I will harm, is treatment like a placebo which has a harmful effect. Types of blinding: single blind, the subjects are not knowing the group to which they are belonging. Double blind trials, neither the subjects nor caregiver is unaware about the groups. And triple blind trials, the subject, the caregivers, the doctors, and the person doing the analysis are not aware about the groups. Advantage of RCT: expose is under control. Due to randomizing, both intervention and control groups have similar characteristics. By blinding the study, the observer and selection bias can be eliminated. If properly designed and conducted, can reduce the confounding, can confirm or refute etiological hypothesis, can evaluate the efficacy, effectiveness, and efficiency of health services. Best method for studying causal relationship, the only study. Disadvantage of RCT: ethical problems, as I have discussed. If the participant do not know what are they getting, so that is an ethical problem. Due to adverse effects, maybe there may be adverse effects of the intervention. For example, if you are administering a drug to the individual, it may bring about some changes in their physique in the form of side effects. Due to benefits of intervention in the treatment groups, provision of placebo, which is an ethical issue and relatively expensive. It needs a lot of money to be conducted. Quasi-experimental is just like experimental design, but it has it does not have randomization. In a quasi-experimental, at least one characteristic of true experiment is missing, either randomization or the use of separate control group. But more specifically, the randomization part is missing. This criteria is missing in the quasi-experimental. Quasi-experimental, say, however, always includes manipulation of independent variable that serves as the intervention. One of the most common quasi-experimental design uses two or more groups, one of which serve as a control group in which intervention takes place. Both groups are observed before as well as after the intervention to test if the intervention has made any difference. The subject in the group study and control groups have not been randomly assigned. There is no randomization. And this is what the method of inquiry is. You have to take the study group before, do an intervention, study group after the intervention, and then if you have a control group before, there is no intervention, and then after you have to collect the data, and then you have to compare in the intervention and non-intervention. You can take a single group and you can take two groups for comparison purposes, but there will be no randomization. Another type of design that is often chosen is it is quite easy to set up uses only one group in which an intervention is carried out. The situation is live before and after the intervention to test if there is a difference in the observed problem. This is called a before and after design. And this is the way of inquiry, the method of inquiry. You have to select the group before the intervention, then do an intervention, and after the intervention, you collect again the data, and then you compare before and after the effect of the intervention. Analytic study types and strength of evidence. Analytical design involves a systematic evaluation of suspected relations, for example, between exposure and health outcome. Analytical design typically provides stronger evidence concerning particular relationship, and experimental design is the only type of study design that can actually prove causation. And this is another explanation. First, we have to do animal and laboratory research, then case control and case series, case control studies, then cohort studies, and at the end we do randomization control trials, then the systematic reviews, and at the end we do meta-analysis. This is how do we conduct research. First, which type of study, and then followed by another types of designs. And these are the references. Thank you very much. If you have any question, you can give your feedback, share this video with others so that maximum number of learners may be benefited of these videos.